Okay, let's take a look at an inverse variation problem. With inverse variation problems, you'll have some function equals k, your constant of variation here, divided by x instead of multiplied by x. And here you could write it also as y equals k over x. So here's our example. It takes 5 roofers 6.7 hours to put a roof on a home. If time required is inversely proportional to the number of workers, then how long would it have taken 3 roofers, and what is the constant of variation? So let's go ahead and write down an equation for this inverse variation. We know that the time it's going to take to put the roof on is equal to some constant over the number of workers. So here we can see that the time is inversely proportional to the number of workers. Now for our first piece of given information, it says that it takes 6.7 hours, that's time, okay, with 5 workers. And now what we're going to do is solve for k. So we'll multiply both sides by 5. So I'm going to take 6.7 times 5, and I'll get that k is equal to 33.5. Okay, now what we're going to do is we're going to answer this question of how long it would have taken to do the roof with 3 workers. So with 3 workers, all I'm going to do, since I know what k is, I'm going to go back to my original inverse variation. I'm going to replace k with 33.5. And now using this, I can go ahead and replace my w, the number of workers, with 3. So t will be equal to 33.5 over 3. So 33.5 divided by 3 gives us approximately, let's say, 11.17 hours. So you can see that we can use this relationship in the first piece of given information and the fact that we were told that it was inversely proportional to come up and determine how long it would have taken to do the job with less workers, 11.17 hours. And remember, our constant of variation was 33.5.